Hi, we're going to look at derivatives and rates of change. Now, the first thing we're going to talk about in this section, though, is tangents. We already talked about tangents before, but here we've got a slightly more concise definition. The tangent line to a curve at a given point is the line through that point with slope m, where m is given by these two expressions, these two limits. Turns out these two limits give you the same thing. And I want to show you where this comes from. So what I want to do, I want to start out by drawing in a function. It doesn't really matter what it looks like, but I'm going to do this. Here is one point, and I'm going to call this point a f of a. And then we're going to have a second point, and we're going to draw a secant line through there. So I've got that line. And remember before we would do this, and we would take the second point, this like movable point, and move it back close to this point, and then see what happens to the slope of the secant line. So let's calculate the slope of the secant line. Let's see, this point, it's I'm going to call it x f of x. And now if we look at the secant, if we look at its slope, it's going to be the difference in y over the difference in x, coordinates of these points. So we get this formula here. And the way we get the tangent is by moving this point back close to this point. If we do that, x approaches a, which is what we're looking at there. So this gives us the slope of the secant, and when we take the limit, that gives us the slope of the tangent. Now, this other equation gives us the same thing. I'm going to do this one in red, because really all we're going to do is we're going to relabel this point. Instead of calling it x f of x now, I'm going to call its x coordinate a plus h, and its y coordinate f of a plus h. And if I do that, I mean, it's still the same line, so it's going to have the same slope. But this time, if we put this together, we're going to have f of a plus h minus f of a for the change in y. And on bottom, we're going to have a plus h minus a, or in other words, just h. So this is two different ways we can come up with the formula for the secant. And on this one, if you take this point and move it toward here, a plus h is approaching a, or in other words, h is approaching 0. So we can use either one of these two formulas up here to come up with the slope of the tangent line. All right, let's look at an example. Basically, what we're going to be doing is, for this example, find the slope of the line tangent to this curve at a equals 3 using both of these methods. All right. So really, what we're doing is we're taking this function f of x and we're kind of plugging it into this formula here. Well, we've got to do both formulas, but let's look at this. I'm going to copy that formula down here. X goes to a, f of x minus f of a over x minus a. All right, so for this formula, let's work out what those different things are. F of x we've already got. F of a seems almost a little silly to write it out, but f of a is a squared plus a plus 1. Oh, wait a second. A is 3. I don't even need to write that out. F of a is f of 3, which is 3 squared plus 3 plus 1. So that's 13. And so what we're looking at here is m is the limit as x goes to 3 of f of x minus f of a. F of a we worked out is 13. And on the bottom we've got x minus a, so that's x minus 3. Now those parentheses aren't really important, but I put them here because of one thing. I want to show what we've got here. A is 3, and so we've got f of x minus f of a. And on the bottom we've got x minus a, x minus 3. Now, when we do a limit, the first thing we do is plug the number in, but whenever you set up a limit like this for finding a tangent line, it's always going to give you 0 over 0. So instead of plugging the 3 in right now, let's go ahead and combine the top and see what we get. All right, so this is going to be the limit as x goes to 3. The top is x squared plus x minus 12 over x minus 3. So x goes to 3 of the top I can factor into x minus 3, x plus 4 over x minus 3. We can cancel, and we're left with the limit as x goes to 3 of x plus 4. So I just get 7. So this graph has a tangent line with a slope of 7 at a equals 3. So that's using this method. Now let's do it using the second method. M equals the limit as h goes to 0 of f of a plus h minus f of a over h. And now before I fill this out, or before I do anything else, I'm going to come back in, I'm going to replace both of these a's with 3. All right, if I plug in 3 plus h into my original thing here, my original function, I get 3 plus h squared plus 3 plus h plus 1. And again, I'm going to put some parentheses around that just to emphasize that that is f of 3 plus h. Minus f of 3. Well, we already figured out f of 3 is 13. And this is over h. So we've got to work this out. If we went ahead and plugged in h equals 0, we're going to get 0. Let's look at that one because it's going to be really simple here. If you plug in 0 for h, you wind up with 9 plus 3 plus 1 is 13 minus 13. So you do get 0 over 0. So what we need to do is FOIL this guy out and combine everything, and we should be able to simplify it somehow. So let's see. I got to keep my limit as h goes to 0 until we can actually plug the 0 in. So let's see, up top this becomes 9 plus 6h plus h squared plus 3 plus h plus 1 minus 13 all over h. Okay, now nice things should happen. Let's see, if you look at this, you've got 9 plus 3 plus 1, that's 13 minus 13. Basically, everything that doesn't have an h in it is going to cancel away. So on top, we're left with, let's see, h squared. So that's this guy. And what else? Plus 7h. And on bottom, we've just got h. So I can cancel an h out. Since everything on top has an h in it and the bottom is just h, I can cancel this out and just get h plus 7 over 1. Now I'll plug in my 0 for h, and I just get 7. So that gives me the answer. And notice both ways gave us 7. And for fun, let's look at it on Desmos. On Desmos, if I put this in, f of x equals x squared plus x plus 1. And then we look at the, let's see, at a equals 3. Well, we saw that when a is 3, the y value that goes with it is 13. So let me pull this down so we can see it. And this is saying that the tangent line at that point is going to have a slope of 7. So if I put in y equals 7x plus b, that right there should give us our tangent line if we found the correct b. Now, I'm not going to go through and try to find it. It wouldn't be that difficult. But it's not part of the problem, so let's don't do it. But if I move this until it touches right there, this is the tangent line. Yeah, it looks like when b is -8, that's the tangent line. All right, we've got some more examples to do. Actually, no, we don't. From there, we want to talk about derivatives. So I'm going to put derivatives in the next video.